Hey guys, today we're going to be talking about integer exponents, so let's get right to it. Integer exponents can be really tricky for a lot of students. I feel like there's like a point when they understand the concept and then all of a sudden it becomes really easy. This is one of those topics. So, for example, if we had 3 to the fourth power, what that represents is this number here multiplied by itself 4 times. Okay? So if we have 0, it's one of these unique rules where any number besides 0, raised to the 0, of course, which is indeterminate, is just the number 1. So 4 to the 0 is also just the number 1. The concept that comes up the most that people have trouble with is when an exponent is negative. Okay? What does that mean for us? What that means is it's essentially this exact same number here, 3 to the 4, but the reciprocal. Kids always get these words mixed up. Negative, opposite, reciprocal. Opposite doesn't mean much in math, but it's definitely not the negative. It's going to be the reciprocal of the number, which means that it is equal to 1 divided by 3 to the 4th. And if you remember from here, what 3 to the 4th was, is 3 times 3 times 3 times 3. Okay? So, let's go ahead and do an example here. So, if we have given this function and we want to evaluate the function at a given x. Essentially what we're doing is we're taking this function and we're replacing x, the variable, with a 2. Okay? So that's going to be f of 2 is going to be equal to 20 times 3 to the 2. Okay? If you remember your order of operations properly, this should be 20. 3 squared is 3 times 3. So that's going to be 9. Okay? Which then is 180. All right. Let's try the next example. F of 0. Well, we just discussed this. If we plug in 0 for x, let's see what happens. What is 3 to the 0? If you recall from earlier, that's one of these special rules where 3 to the 0, or any number to the 0th power, actually just is 1. So this one is simply 20. Okay? Let's try this next one. This uses the third rule that most people get confused on. So let's take our time here. F of negative 2 is going to be equal to, we're replacing x with negative 2, so it's 20 times 3 to the negative 2. What's 3 to the negative 2? Okay. 3 to the negative 2 is the same as 1 over 3 to the 2. It's the reciprocal of that value. When you do the reciprocal of a number, the power becomes negative. So if it's already negative, then you do a negative of this and it becomes positive on the bottom. Okay? So we already established that 3 to the negative 2 is 1 over 3 squared, which is the same as 1 over 9. So f of negative 2 is equal to 20 times 1/9. 20/9. Cool. All right. Let's learn another concept here. And this is in regards to multiplying powers. So, if we have 3 to the 2nd power, and then we multiply it by 3 to the 5th power, what's the rule here? So if you think about this broken down, this is 3 times 3. And this is 3 times 3 5 times. So 3, 3, 3. What happens when you multiply all of these 3's together? There's 7 of them, so it'd be 3 to the 7th power. The rule here is that 3 to the 2 times 3 to the 5th would be the same as 3 to the 2 plus 5, which is 3 to the 7th power. Okay? When you multiply these integer exponents, the exponents add. So it's very, very kind of sounds backwards, but it's just one of those rules. So when these multiply, the powers add, okay? And it works for even negative numbers. So if you have 3 to the negative 3 times 3 to the 5, that's the same as you're adding the exponents. So it's the same as 3 to the negative 3 plus 5. And what's negative 3 plus 5? Well, that's 2. Okay? So, that being said, let's try this next example. So for each of the following, write the product as a single exponential expression. So these are multiple exponents here. So we want to combine this into a single expression. So 2 to the 3 times 2 to the 4, what did we learn about that? When you multiply, you're going to add the exponents. Okay, so this is the same as 2 to the 3 plus 4, which is 2 to the 7th. Okay, let me use a blue pen here. This is another similar example here. So 2 to the 6 times 2 to the 2 is the same as 2 to the 6 plus 2, which is 2 to the 8. Okay. This one looks a lot more confusing, but in reality, you're just using the same rules. So what I always tell my students is when you see something that you don't know, try to remember the rule that you learned regarding it. Because whenever you see something that's, especially when you're using all these characters, A, B, C's, X, Y, Z's, the rules seem to break down for a lot of students. So let's remember what this rule is. So we're going to, when you multiply, you're going to add the exponents. Okay? So it's going to be 2 to the m plus n. Okay? Simple as that. The thing is that this doesn't turn into something like an actual number. 2 to the 8 you can plug into your calculator. The reason this is confusing for a lot of people is that you can't actually plug this into your calculator. However, what was the instructions of this problem? It's to write the product as a single exponential expression, in which we did. Okay. So, the next concept here is going to be instead of multiplying exponential expressions, we're going to be raising them to a power. So if you have 3 squared raised to the 5th power, this is not the same as 3 as we learned earlier, okay? This one is you're multiplying the terms, so you add the exponents. This one, you're raising the power to a 5, so you're going to multiply the numbers. 3 squared to the 5th is kind of the same as that quantity multiplied 5 times. 3 squared to the 5th is going to be the same as 3 to the 2 times 5. Different than the adding that we did earlier, which is 3 to the 10. Okay? And this works for positives and negatives alike. If you have 3 to the negative 2 raised to the 4th power, because you have an exponent raised to another exponent, you're going to multiply the exponents. 3 to the negative 2 times 4, which is the same as 3 to the negative 8. Going one step farther, if you remember what 3 to the negative 8 is, it's actually the same as 1 over 3 to the 8. This can be written either way. Okay, so let's go over an example. So for each of the following, write an exponential expression in the form 3 to the x.